Again, welcome to Mathematics 164 Pre-Calculus. This lectures cover chapter 3 of our course textbook, which is Matrices. Our main objective is to learn how to organize and also interpret data stored in matrices. We're also going to learn how to add and subtract matrices, and also how to find the transpose of a matrix. We're also going to learn how to multiply a matrix by a scalar. A scalar will be any real number. So matrices are normally classified in terms of the number of rows and also the number of columns. So a matrix consists of rows and columns, same as a table. So for example, here we have a matrix M, and we have 3 rows and 4 columns. So the size of a matrix will be 3 by 4. Again, not 4 by 3. Always the size of the matrix, the row comes first before the column. So in this matrix M, the size is 3 by 4. Another example of a matrix A, we can see that we have n columns because we have 1n. Then we have M1 up to Mn. So this matrix, the size will be the number of rows times the number of columns, or by the number of columns. So here, the size will be m by n because we have m rows and n columns. Always the subscript, the first value will be the row position and the second value will be the column position. So we also say that two matrices are said to have the same order, which means they have the same size if the number of rows and the number of columns are the same. So for example, here we have matrix C. The size is 2 by 3 because we have 2 rows and 3 columns. Matrix D, we have 3 by 2 because we have 3 rows, 2 columns. So these two matrices are not in the same order. They are not the same size. So here we say C is 2 by 3 and D is 3 by 2. So C and D do not have the same order, or they are not the same size. Now we say the numbers in the matrix are called its entries, or the elements, and also the subscript on an entry in matrix A. In the previous slides, let's go to this slide. For example, this matrix A, the subscript here is 1, 1, which means it's in the first row, first column. So for example, here we have A 2, 3. It means the value is in the second row, third column. So the subscript always, the first value is the row position, and the second value again is the column position. Now we also say that a matrix is a square matrix if the number of rows and the number of columns are the same, then it's a square matrix. So for example, here we have a matrix B. The number of rows are 3. The number of columns are also 3. So this is a square matrix, 3 by 3. Also, we have a matrix. The number of rows are 3, but the number of columns are 1. So we normally call this matrix a column matrix. So we say a matrix with 1 row, such as 9, 5, or 3, 2, 1, 6, which means we have 1 row, 4 columns. It's called a row matrix. A row matrix means the matrix have only 1 row. And then a column matrix means it has only 1 column. And normally, a column matrix or row matrix, we also call them a vector. This is a common term we use in linear algebra. A vector means we have only 1 row, 1 column of a matrix. So here we say the rows and column matrices are also called the vectors. And any matrix in which every entry is 0 is called a 0 matrix. So example, here we have 2 by 2 matrix. It's a 0 matrix because all the content are zeros. Now we can define two matrices to be equal if they are of the same order, which means the size of the two matrices are the same, and also the entry in both matrices are the same values or the same entry. Then we'll say that the two matrices are equal. Now, when a columns and a row of a matrix are interchanged to create matrix B, so let's say we have matrix A, the columns of and the rows of matrix A are interchanged, then we will say it's a transpose. So in this case, if we represent it as B, then we say matrix B is the transpose of matrix A, which is A to the power T is equal to B. So A transpose is equal to B. So let's see an example here. We have a matrix A, the size is 3 by 3 because we have 3 rows and 3 columns. Matrix B also the same, the size is 3 by 3. The first question is, what is the element or the value at A, lowercase a, 3, 2? So since the matrix A, the name of a matrix normally we use the uppercase and the element will be lowercase. So I'll go to matrix A because this is lowercase a. And I'll go to the third row, second column, 3, 2. So this means the value will be 8. And actually the answer is in the next slide. So A, 3, 2 is equal to 8. Then the second question said, is A a square matrix? Yes, because the number of rows and the number of columns are the same. So matrix A is a square matrix. Now to find the transpose of matrix A, the answer will be, instead of 137 as a column, 137 will be a row. Then 048 will be a row and 323 will be a row. So we change the rows to columns and we have again the transpose of A. Now does A and B equal? The size is the same and the element also must be the same, but we can see that in third row, third column, we have 3 for A, and third row, third column, we have 4 for B, but the rest of the values are the same. So matrix A is not equal to matrix B. So that's the A, and the first answer, the element A, 3, 2, the answer will be 8 because 8 is in the third row, second column of matrix A. Then B, we say yes, the matrix A is a square matrix. Actually, both of them are square matrix and the size is 3 by 3. Then we find the transpose of A. Previously, matrix A, the first row is 103. So we change it to a column. Every row are changed to column, or every columns are changed to a row. Then we find the transpose of it. Then we say that the matrix A and matrix B, they are not the same because A33 and B33 are not the same value. So this is our matrix A. The third row, third column is 3. Matrix B, the third row and third column is 4. So both matrices are not the same. Two matrices are equal if the size is the same and also the element in each positions are the same. So next we will go through the addition and subtraction of matrices. Now, if you have 2 or more matrices and you want to add them or subtract one from the other, the first rule that we should know is that the 2 matrices must have the same size. They must not be equal, or they can be equal, but the rule said they must have the same size. So if 2 matrices have the same number of rows and also the same number of columns, then we can add or subtract the matrices by adding or subtracting their corresponding entries. So matrix A value at A11, I will add it to matrix B value at B11. The position must be the same. So that's the rules here. So we have matrix A, B. We can see that matrix A size is the same as B size. So I'm going to add A11 plus B11, A12 plus B12, A1N plus B1N, then A21 plus B21, A22 plus B22, and A2N plus B2N. Then AM1 plus BM1, AM2 plus BM2, AMN plus BMN. And the answer we may say is a new matrix C. So we should know that the sum of A and B could be found by adding the matrices in either column. So in matrix addition, A plus B is the same as B plus A. And this is what we call the commutative law of addition. Also, a matrix negative B, which is a negative matrix, is called the negative for the matrix. And each element of negative matrix B will have a negative corresponding element of B. So, for example, we have a matrix. B is -1, -2, 2, 0, -3, and 1. Now, if I'm going to look for negative B matrix, then I'm going to multiply -1 by all the elements or the values. So 1 will become -1 if it's -1, or B is -1. So negative B matrix, -1 become +1. +2 become -2. -3 become +3. -2 become +2. 0 will be 0. Then 1 become -3. Now, using the negative, we can now define the difference between A and B. So if I'm finding the difference of a matrix of A and B, basically I'll just subtract the B from A in each element position. So we have an example here. This example generated data for us. So we have Canada, Mexico, and other countries. Their exports for 2015, 2020, and 2025. We also have their imports for 2015, 2020, and 2025. Now we want to find out if these two countries and other have any balancing trading. So here we say table 3.2 summarizes the actual and projected US dollar values in billions of US export and import of pipeline natural gas with Canada and Mexico, and of also liquefied natural gas with other countries for selected years. Now write the matrix that would describe the balance of the trade. For example, Canada in 2015, do they export more than they import, or do they import more than they export? And we are going to find that for all the two countries and other countries. So we are going to write this in a matrix form. So, for example, the export section will be our matrix A, then the import section will be matrix B. So we have the matrix A, the values for the export, the import. Then in order to find out if they are balanced, we have to find the difference. So we subtract the import from the export. Now, if we subtract an import from export and the answer is positive, that means it's good. The country export more goods than importing in economic sense. Now, if it's negative, that means the country import more goods than they export, which is not good for the country economics. Now, if it's 0, it means it's balanced. The amount we import is the same amount we export. So we find the difference of each value at the correct position. So 3.15 minus 10.13, then 5.76 minus 12.05, 6.53 minus 11.39, then 2.99 minus 0.20, 5.87 minus 0.21, and 7.83 minus 0.11. Then we do that also for the third row. So the final solution, we find the difference of each values here. And this is what we have. Now we can see that the negative section means the country, again, import more goods than they export. So here they say we should know that any negative entry indicates an unfavorable balance of trade for United States with the country in the year corresponding to that entry. In a sense of economics, again, we want to make sure we export more than we import. So that will take us to the next section, which is the scalar multiplication. As we said, the scalar means any real number. So for example, if I have a matrix 2 by 2, A11, A12, A21, A22, and I want to multiply scalar value C to matrix A, then all we need to do is to multiply C by all the elements. So A11 multiplied by C, A21 multiplied by C, A12 multiplied by C, and also A22 multiplied by C. So let's see an example here. We have a matrix A. we can see matrix A is 3 by 4. And they say we should find 5A. So this means I'm going to multiply 5 by all the elements in the matrix. Then also we're going to find negative 2A, which means I'm going to multiply negative 2 by all the elements in matrix A. So first, the 5A will be 5 times 4 times 2 times 0 all the way to 5. So we multiply 5 by all the elements. And our answer will be given as following. 20, 10, 0, 5 minus 35, 0, 21, 5, 10, and 0, 30, 25. Now the second is minus 2. So we multiply negative 2 by all the elements. Negative 2 times 4, negative 2 times 2, negative 2 times 0, negative 2 times 1, negative 2 times negative 7, etc. And our final solution will be this. So that will be the conclusion of our lectures. Again, these lectures cover chapter 3, section 1 of our course textbook. And we learn the concept of matrix, the definition, and some few terminology. We also learn how to add, subtract matrices, and also how to do a scalar multiplication of a matrix. In our next lecture, which is 3.2, we are going to learn how to multiply two matrices. Again, thank you for your time.